Today, I got to test the world-famous spot robot by Boston Dynamics, and I did a tour at the Boston Dynamics office where I learned about their history, how they went from being a project at MIT to becoming a large company making these incredible robots. I spoke with a vice president in the company.
I'm Brendan Schulman. I'm Vice President of Policy and Government Relations at Boston Dynamics.
And I asked the age-old question, are robots coming for our jobs? Without further ado, let's get to the video. Boston Dynamics has a smart robot dog called Spot, which many people have seen before, and I got to test it out. It can walk over objects while detecting them and adjust itself smartly. It can climb flights of stairs without falling down and avoid people, just like it avoided me here. But there's so much more that it can do.
So our best known robot is Spot, and we designed Spot as a general purpose quadruped robot. So it's useful in a variety of different applications. In fact, we're still discovering new uses for Spot. But Spot's main use is in industrial inspection. So if you imagine a manufacturing facility or maybe a power plant, Spot is doing inspection rounds, autonomously walking around, taking measurements of equipment, checking to make sure that the equipment isn't overheating, if there's coolant lines, those aren't leaking. That's a very useful kind of maintenance operation. But Spot is also useful in situations or environments that are dangerous. So nuclear power plant decommissioning, for example, sending the robot in to check on radiation levels, to map the facility. That could be after an accident, like in Fukushima, or it could be just part of the decommissioning process. That's another way in which the robot is used. And then there's public safety, situations that might be dangerous for humans to enter. Could be suspected explosive situation, like a bomb squad kind of robot, or hazardous materials or hazardous situations. So for example, the fire department of New York had a situation where they had a parking garage collapse. This is about a year and a half ago. And they sent in their Spot robot to look for victims or survivors of this building collapse in Lower Manhattan. And they were able to find someone, unfortunately, who was deceased. But what the robot was able to show them in real time, in a safe manner, was that there was no one in the building to be rescued, and therefore they didn't have to send in firefighters at risk to themselves because this was an unstable structure. They saw there wasn't anyone left to rescue inside, so they were able to deal with the situation safely. So industrial inspection, manufacturing, energy, public safety, any situation where a person could get hurt is a great situation to put a robot into.
Imagine that thing like crawling up the side of your building. We talk about science fiction.
This is 30 years now
Yeah.
that Boston Dynamics has been creating this. And in 30 years, you've definitely encountered some challenges. Like, can you talk about those challenges?
There are two groups of challenges. There's the technology challenge, right? We need the robots to be very reliable. We need them to work and do the mission so that there's value for the customers. These are not inexpensive devices, they're industrial robots. So one challenge is make them super reliable. And as you can see in our facility here, we have robots walking around 24 hours a day, 7 days a week, engaged in different kinds of missions so that we can understand when does a robot fail, how can we make that better? So if a part breaks, or there's a software bug, we're using those reliability tests constantly with fleets of robots in the back here to make the robot better from a technical perspective. So that's one way that we've spent all this time making the world's most reliable quadruped robot. But then there's another set of challenges that I think is ethical and societal. And that's just the introduction of these advanced robots into society is something that in some cases excites people, but in other cases causes them to be intimidated, to remember the movies they've seen, the science fiction, the Terminator or Black Mirror episodes, things like that. And so we've been working very diligently right from the beginning of our launch of Spot. We wanted to make sure that this is a tool that's going to be used to help people and not hurt them. So in our terms and conditions of sale, it's prohibited to arm the robot, to weaponize it, or to use it in a way that would harm or intimidate any person or even an animal. That's right in our legal terms when you buy the robot from us. So that was the beginning of our ethics engagement. Try to be responsive and get ahead of the issue of people worrying about the robots hurting humans. We've also done a lot more since then. I'm engaged in policy development, working with lawmakers to try to make sure that robots are used responsibly. And we can talk a little bit more about the kinds of policy work that we're doing in collaboration with others, but really I see those as the two challenges, technical and then societal. And we're engaged in leading the efforts in the industry in both ways.
The start of the company really was, it launched from an MIT spin-out. So on the screen here, you see the videos from the leg laboratory at MIT. And really, these were experiments in making robots more mobile. So you see early experiments with legs, jumping around, walking. That on screen now is actually this robot here. And that was the PhD thesis of our CEO, Rob Plater. So you're looking at his academic robot. He was a gymnast. So his thinking is, could we make a robot run and flip and do somersaults like a human gymnast? And then from 2 legs to 4 legs and on from there. So from Big Dog, you get sort of the beginning of like Spot version 1. I don't think it had a name at the time. And here you're starting to see that things are becoming electronic rather than hydraulic. You've got the beginning of a gripper with an arm. It's still kind of big. It's still not really suitable, but you also have sensors. Actually, let me just add one intermediate step here. So we saw the LS3 on the video. This is the actual robot. We go from robots that can't perceive the environment to ones that can. So this has camera sensors and a LiDAR for detecting obstacles. And it also has an infrared strobe. So this was used to create a kind of like an automated following feature. So if you wore a vest, the robot would follow you and would avoid obstacles like trees and rocks. So this robot is basically doing a lot of the things that Spot does today in terms of sensing and avoiding obstacles and doing automated missions. In this case, instead of having to be controlled by someone directly and manually, just walking behind you, because it was designed to carry things.
Are you seeing more law enforcement use these robots now? Is it just in Massachusetts or?
No, we have at this point probably a few dozen law enforcement customers. It's not a big part of our business.
Okay.
Most of the Spot robots that are sold by far are industrial applications, manufacturing, energy, utilities, that kind of thing. Because the robot is really useful at inspecting things from a distance, like a suspicious package, or in the event there's an armed standoff barricaded suspect scenario, the robot is also useful for taking a look at that situation. I'll give you an example. We had I'll give you 2 examples. In Florida, this is now about a year or 2 ago, we had a 3-year-old child who was kidnapped by a person in a pickup truck and driven onto the highway. The truck crashed on the side of the road in a sort of grassy area. At that moment, typically law enforcement would try to figure out a way to approach the vehicle to rescue the child, but they were worried that the suspect was armed. Well, they sent in Spot to take a look through the window, through the remote camera stream, and they're able to see that there was no weapon, no firearm. So they went in and they rescued the child, which is a great result, and they were able to do that without having to escalate the use of force. Similarly, in Los Angeles, shortly after LAPD acquired their robot, on the very first mission, they had a similar armed standoff shootout scenario, and the robot was sent in and literally removed the weapon from the scene, de-escalating and basically disarming the people in that scenario before they sent in the law enforcement officers. So in situations where there's a hazard, a danger, send the robot in, figure out what's going on. In some cases, the suspect is passed out, is asleep. We had another example we've been told of again, a similar tense situation. They send the robot in and they determined that the suspect was passed out on the floor and the weapon was like several feet away. That was a good moment to enter and safely resolve the situation compared to a few minutes or an hour earlier when the suspect was awake and within reach of the gun. So you have really a tool that can help provide live information to those who are responding to a dangerous situation. So we've had really great stories, even though it's a small part of the market, and it's also, we recognize, a part of the market that raises concerns about law enforcement use of technology. So we've been working in that area too, to engage and address the concerns, but also really to make sure people understand what are these machines doing in the communities that we think is protective of life and safety.
I learned that there's, apart from sports, there's another robot. Is it called Stretch?
Yes. So yes.
You said one is used more for industrial. Is that the robot used for industrial purposes?
Yeah. So Stretch is our automated warehouse robot, and it does not have legs. It has a large rolling base the size of an industrial pallet, with a mobile arm with a suction cup gripper. So what that robot is used for in its first application is unloading boxes from a truck. So you point the robot at the back of like a trailer, like a cargo container. The robot will roll in and start automatically picking up the boxes and putting them on the conveyor belt that leads into the warehouse. So it's an automatic truck unload. And in the future, that robot will also roll around the warehouse, picking up boxes and building a pallet of different things to send out to the customers. So it's an automated warehouse robot. And there are a lot of warehouses and boxes in the world. Like, this is actually a very large market. So you have Spot, which is the general purpose quadruped robot dog, doing a lot of different things, like we discussed: law enforcement, manufacturing, energy, facility inspection, historical. There's the folks at Pompeii use Spot to map it. So that's a general purpose robot that you can put anywhere because of the mobility. Stretch is designed for warehouses, so it's wheels, and a very powerful arm to lift 50-pound boxes.
I feel like you said this: lift 50-pound boxes, do stuff that humans don't necessarily want to do. But people always think about robotics and think, oh, these things might take our jobs. Where do you stand in, it's going to supplement jobs, or it's going to take the jobs? Like, for sure, there are some jobs that will be lost because of robots, like the offloading and certain things. How do you address such statements, basically? Yeah,
that's a really important ethical issue that we are engaging on. So a couple of thoughts. First of all, that is the story of all technology, right? Including the laptop that you have and our mobile phones. Like, we don't call the operator anymore to place a call. It's just all automatic. Robots, though, are a very physical type of technology, especially the humanoids that we're working on, where you will feel the potential job change, employment impact, more than you might for an electronic switchboard that you never see.
But this is the beginning of sort of humanoids, and then we were asked to design, this is a DARPA-funded kind of robotics challenge. Can you create a humanoid robot that different teams can use to compete? So we made these Atlas robots for science competition funded by the government. So that was the beginning of this Atlas, and then if you kind of wander back here, various different iterations of Atlas, and including putting weights on the robot, again, to kind of make it, kind of push the limits and test it. And then ultimately, the Atlas that you see in our videos, which can do parkour and flip and stuff like that. So this is the evolution of Atlas. It's actually, some people remark that it's shorter than they expect. I think it's only about 5 feet. But that's the Atlas. And of course, now we're working to commercialize the humanoid robotics.
So it's certainly important for us to engage with our customers and with the government to figure out what can we do to address the changes in labor that will occur as certain industries become more automated. is the kind of thing that happened with automotive manufacturing and other things, but sure, it will happen with warehouse robots too. I think it's really important that we focus on, the end goal here is to make the jobs better and safer for whoever has them. And have the person who today is lifting a box all day long be the person who is supervising and managing and maintaining the robots who are doing the lifting. So there's still plenty of work, and like I said, the demographics are such that we don't have enough people to do these jobs. If you talk to the folks who run warehouses, they will tell you, we can't find enough people to do the boxes. So what we want to do is have the people who would today do the boxes running the robots, maintaining, we call it the robot wrangler, right? Wrangling the robots, managing them, maintaining them, organizing them, having them do more sophisticated tasks, be the robot expert in the warehouse, not the physical, basically using their bodies as a machine. And we've seen that. If you look at like some of the videos we have about Stretch on our YouTube channel, you'll see that in the warehouse environment, people love the robot. They're really excited that the robot is doing the thing they hate, and they're excited to use it. And I think that's really the future. So it's not unique to robotics, and I don't think we should imagine that robots are going to take more jobs than any other technology, but it's something that we are talking to folks in Washington and elsewhere about. How can we ensure education, training, and workforce development in the automated industries of the future, including with robotics. And we would love to be part of that. So that's kind of like ethics topic number 3 that I work on, is what can we do? And if there are people out there who are engaged in thinking about this issue, we would love to talk to them, because we do think, especially with the AI coming, the robot adoption is going to accelerate. It has to, because of the demographics. How can we be part of making sure everyone is ready for that and has the jobs that they want?
Well, these are the prototypes that led to Spot. So you're kind of looking at the lab version of what became Spot. So making it smaller and making it electric those were necessary in order to create something that could actually be useful in a commercial environment. Be careful touching this. These are fish hooks. So there's sharp little claws made out of like the hooks that you would use for fishing, all in a row. So that just grabs onto the side of the building and can crawl up. You talk about science fiction. Imagine that thing like crawling up the side of your building. So again, these are all research type projects.
So the Responsible Robotics Act is a bill that we helped develop with the ACLU of Massachusetts and with 2 lawmakers in here in Massachusetts. It very generally prohibits the weaponization of a robot or drone, or the use of a weaponized robot, or the sale. So basically, you take a robot like Spot or anything else. If you put a weapon, which is defined in the Responsible Robotics Act as a device that is designed or intended to harm or kill someone. So if you take a gun or a bomb or like a stun gun or a flamethrower, and you attach it to a robot, you are in violation of that, and there's a penalty for doing that. There are narrow exceptions that we developed in discussions with the stakeholders for the bomb squad, right? So we wouldn't want to stop law enforcement from detonating a suspected bomb. That's really important. And in informal discussions with law enforcement folks, they said, yeah, we sometimes have to do that. And so we don't want the definition of robot or weapon to include things that no one objects to. And so that's carved out of the bill. Also carved out of that bill is the Department of Defense and defense contractors. There's a whole discussion going on internationally about lethal autonomous weapon systems. This bill is not about autonomous robotics, it's about any robot. So even like the most basic robot would fall under the act. It's not the discussion you may hear about elsewhere about lethal autonomous systems used by the military. There are existing international frameworks that address military use of weapons systems. There's accountability, there's congressional committees that can address what military does with weapons systems. and it's not the role of state government to regulate our national military. So that's carved out of the bill. But otherwise, across the board, if you were to develop a robot with a gun or a flamethrower or something that could hurt someone, and you were to sell it or use it in the state, once the legislation is passed, you would be violating the law and subject to a penalty.
Thank you so much.
I know you'll enjoy it. This has been a great discussion.
Yeah, thank you.
Thank you for the opportunity.